In class 4, we're going to take an advanced approach to compression, right? So as if that didn't blow your mind as enough, now we're going to get into how you take like a practical application of compression to another level, right? So now we're going to get a little more advanced. And we're going to talk about using vintage compressors. So what's important about vintage compressors? Like you always hear like, oh, I want a Neve compressor. I want an SSL compressor to really make it pump and come alive. I want to use, an old Fairchild compressor, right? And all these different types of compressors. Well, what is it that's so special about them? What's so special about them is the characteristic way in which they apply compression. They start to use different components which add unique characteristics to the sound. So certain compressors are optical compressors. All right, so when we talk about compression, you have optical compressors, and optical compressors use photoelectric material, right, to apply compression, right? And one of the characteristics of optical compressors is that they're very smooth sounding, right? Very clean sounding, right? And they have a certain characteristic in terms of the way that they work. Like the release characteristic, instead of being linear, actually happens very quickly, right? The release characteristic is very quick, but then it's slow to go back to uncompressed signal, right? So it has like an S shape to it, right? Whereas a normal like stock kind of digital compressor will have a linear characteristic to the release time, right? So that's really important. Then you have other forms of compression, which is like tube compression, right? And tubes actually are valves actually add a certain sonic characteristics. They add a high frequency buzz or kind of noisy energy, which adds like an air, and they also add a low frequency density, right? So there's high frequency density and low frequency density. And so tube compression adds a lot of size to a mix, right? When you have compressors that are based with transformers, right? When you have transformers actually have a very warming characteristic. So if you have a vocal, for example, that's a bit brittle sounding, maybe it was recorded with a large diaphragm condenser mic and no tubes, and so it sounds a little bit harsh sounding, then a transformer-based compressor, what that'll do is it'll add a warming density to the low mid-range, right? So that adds low mid density. But it also rolls off some very high frequencies, and it rolls off some very low frequencies, and that's why tubes and transformers work really well together. You also have VCA compressors. VCA compressors and FET compressors give you one thing, they give you very fast and accurate characteristics, and they can be very aggressive sounding. So when you want to do that sort of pumping and breathing, heavy kind of compression, then the VCA or FET compressors are kind of the way to go, right? So because these can be really focused on the characteristics of really fast attacks and release times, and you have amazing control over them. Whereas the optical tubes and transformer components have a certain characteristic way in which they color the sound that can't be really manipulated. It kind of either works or it doesn't. And if it doesn't work, then you try something different. But these start to add a tonal characteristic to the sound. And one of the problems that people have when they use these different types of components is they say, hey, I got this Neve compressor, and it sounds amazing on my vocal. I'm going to put it on the bass, and I'm going to put it on the kick drum, and I'm going to put it on the snare drum, and I'm going to put it on the guitars, and they put it on all the instrumentation, and what happens is the effect is completely lost. Because what it did to the vocal is now negated because the same thing is happening to all of the other instruments in the mix. This is critical, understand, because what happens is that, imagine the way I'd like to think of instruments is that if you have all these instrumentation and everybody is wearing sort of the same color shirt, right? You give everybody the same color shirt. Nobody really stands out from anybody. They all look exactly the same. Some people are bigger than others, taller than others, shorter than others, that type of stuff. But if you give one person a yellow shirt, a bright yellow shirt, and everybody else has black shirts, then that person stands out. And that's sort of the way you have to think about applying vintage compression, or things that are unique, have unique tonal characteristics to them. So you start with the vocal. If that's the most important instrument, you want to get that to have its unique character and sound. And when you use a compressor or a vintage equalizer on that and it gives it a certain tonal characteristic, you want to try to avoid using that same processor on the other instruments in the mix, because it will start to negate the uniqueness of that. On the other side, maybe you want to take all the elements of a drum kit and kind of pull them together so they do all sound uniform. And now it sounds more like a drum kit. So if you use an API EQs or compressors and you apply those to all the elements of the drum kit, it will help the drum kit to sound more uniform and more like an individual instrument. Whereas if you applied 6 different compressors on it, it will sound more disjointed, right? So this will sort of make that instrument more uniform, right? And pull it together. Really important. The other element that I get into here in this level of it in terms of working with the advanced compression is multiband compression. And multiband compression allows us to divide the frequency spectrum of 20 hertz up to our high end, which is 20 kilohertz. What we can do here is we can say maybe we want to apply the compression to individual frequency areas. This allows me to compress the low frequencies where I want the density, but leave other frequencies alone. Maybe I want to add a lot of extra presence. So between 2K and 6K, what I do is I do a fair amount of compression in this area to add density so that articulation of the voice really stands out, right? And this way, what I can do is I can help to shape the individual elements, right, or parts of any instrument or voice or whatever or track on a frequency dependent basis. And what this becomes is a dynamic equalizer, right? It's like a dynamic EQ, because now what I can do is I can make this presence frequency only pop out when it occurs in the voice. Because if you have a voice, it doesn't have the same amount of high frequency energy over the course of a whole note. In fact, you really get most of the high frequency energy at the beginning, like the articulation. So if you had a word that was, talk, you said the word talk, most of the high frequency energy is in the T and in the K at the end, the hard consonants. And the note that goes on to sustain is over the vowels and the soft consonants. And that ends up being more low and low mid energy, right? And this energy up here is the presence area, right? So you can actually compress these different frequency areas to manipulate where and how the sound appears in the speakers, right? And multiband compression is really, really powerful. You can use it on individual instruments. You could do it to pull all of your drums and percussion in the mix stem. You could use a multiband compressor to kind of pull that sound together and focus it, right? So that you can have, for example, the low frequencies pumping with the kick drum, the low mid frequencies dipping at the same time this pumps, which helps to sink this down in the speakers. You can have the presence frequencies, so the attack of the snare drum really pops out when that hits. Or, you could have this actually pump up with the snare drum, which is more in this frequency area. So what you have is these things that are kind of pumping the sound for the individual elements that are part of the drum kit, right? And that's the power of dynamic, multiband compression, right? And so that's like a big part of the workshop here as well, right? So we'll get into some of these advanced compression techniques and unique dynamics processors. So now this is getting into some of the things we talked about in the last thing, which is using upward compressors, right? Using expanders, right? Because you can basically, if you, instead of making a ratio 2-to-1 or 10-to-1, you make it 0.5-to-1. Now what happens is for every half dB above threshold, 1 dB comes out. So twice as much signal comes out. And that allows you to take something that is over compressed and make it more dynamic. Okay? And that's a very powerful way. So there's 2 ways to look at it. You can move signals down and bring up the overall gain, or you can move different areas of the attack, decay, sustain, release cycle up, and then you do make down gain, right? So, and they both have kind of subtly different characteristics to them, right? So that's the advanced compression techniques, okay? So let's move on from there.